Okay, so guys, let's continue part 2 of our level 2 of exercise 1. Okay, so in this video we will just be looking at question 3 and question 4. Alrighty, so the first question is, if vector u and vector v are vectors in R squared, prove that the angle theta between vector u and v satisfy this one. Okay, so if you really want, you can draw a diagram, but I wouldn't say we need one. Let's just go ahead and do the usual vector diagram. Okay, so saying vector u and v are vectors in R squared, and prove that the angle theta between them, right, satisfies this. So you just want to draw two vectors, right? Label one vector u and one vector v. Easy. Now that they're saying, let's draw this resultant. Okay, and the angle here, let's name it theta. Okay, easy. That's what they've given us. That's the information they've given us, and we want to really show that the angle theta between this vector u and this vector v is equal to this equation that they've given us. Okay, and this isn't hard. Alrighty, so what we really want to do is that we really want to first show them that we can calculate this in two different ways. First, for this red bit, right? See how it's going from u to v? We realize that this is just vector subtraction. Vector v minus vector u, right? If you know our basics, that is what it is. Now, with knowing this, what we can do is we can prove that this one is equal to two different things and then prove it from there. So I'm going to prove that the angle theta between them is that. So first, let's use cosine rule. Okay, our first proof is using cosine rule, and if you guys forgot what cosine rule is, let me write it here. Cosine rule is equal to a squared is equal to b squared plus c squared minus 2ab cos a. Okay, this is just what our thing says. So using cosine rule, what is our a squared here? This is your a squared. This is angle a. This is your a squared. So vector v minus vector u, magnitude squared. You can only square magnitude, you can't square vectors. Keep that in mind. Okay, keeping that in mind, this squared is equal to, what's the cosine rule? It's saying the sum of the other two sides, so vector v plus the vector u squared, and it's also saying minus 2ab. What's a? Vector v. B, vector u cos theta. Okay, because we do not theta this, let's let this equal to be equation 1. Now, if you think about it more, these are vectors. So you can also go ahead and prove this using vector methods. Okay, using vector methods, what do you notice is that see vector v and vector u, right? You can actually do vector v minus vector u, vector v minus vector u squared. Instead of, you can write this as normal algebra, which is just v minus u into v minus u. That's what it's saying, right? V minus u whole squared is just v minus u into v minus u. And now foiling this out, expanding as shown, we will get magnitude of v squared plus magnitude of u squared minus 2 magnitude of u, magnitude of v. Okay, this is what we get when we FOIL this out. Easy peasy. Okay, and let this be equation 2. Now what do we get from this? Well, you see how both these are equal. This is v minus u, vector v minus u magnitude squared, and this is also v minus u squared. So if this is equal, then the output is also equal. So then we can equate coefficients by equating let's move it a little bit more, so we can just start writing it there. Okay, nice. Now we have enough space here. By equating outputs, right, we get that this output this is equal to this output. Easy. Now now what do we get? Let me just drink a little bit of water. Okay, so see this, both these are equal. What we can do is we can cancel out common terms. This gets cancelled out, it's on both. Minus 2 gets cancelled out, it's on both. And this also gets cancelled out because it's on both. So now what we get is that cos theta is equal to, wait, that's interesting. That's not how this is supposed to go. What am I supposed to do? Oh. Sorry guys. Looks like I made a mistake here. See this? Let's just expand it properly. Looks like I made an expanding mistake. See, this is v into v, which is magnitude of v squared, plus this is minus u into minus u, which is just becomes a plus, the negatives go away, and then magnitude of u squared. Now we have this part, which is v into u and u into v. We have to take that into consideration. V into u, what is that? It's v dot u, okay, but minus. Plus, we have another minus u into positive v, which is just minus u into v. There's no magnitudes here. We're just multiplying the vectors. So then, it's just a dot product. It becomes minus 2 v into u, okay. So minus 2 u into v. So then by equating coefficients, so what, minus 2 u v cos theta is equal to minus 2 u dot v. Yeah, we're just going to equate this. We're just going to equate this coefficient here and this coefficient here. Why? Because this v plus u is common on both, so that just goes away. Now what we do realize is that minus 2 also tends to go away. Let's zoom out, but the minus 2 also tends to go away. So now we have that cos theta, let's take this and let's divide both sides by this magnitude. So then here this will just cancel out, and then this will go to the bottom here. Okay, so cos theta is equal to into v over magnitude and magnitude of v. Okay, and that's our final answer. Easy. Easy proof. Then you can write like hands shown. Now we have another interesting questions. Looks like the interesting questions have not left us yet. Okay, so these questions are rather interesting question because you need to think a little. As always, let's read the question first. ABCD has vertices this, and this. Okay, so we have 3 vertices, so it's forming like a triangle. And they say that too. Find the area of the triangle by first finding one of its angles. Okay, that's a weird request, but they want to find that one of its angles. And angle area for triangles is half BH. But then if they're saying angles, by finding one of its angles first, they're implying us to use half AB sine theta. This is the area of the triangle formula they want us to use. Okay, so now that we got that easy, let's just go ahead and draw a vector diagram. So drawing a vector diagram. Ooh. Looks like I did need to like widen my axes. Okay, so -3, 1 is like here. This is A. B is 3, 4. So 3, 4. And C is -4, 8. A, what are we even doing? Let's first put the points. That is B and that is A. And then we join the triangles. It's not asking for the vectors, bro. It's asking for the triangles. Sorry, I got mixed up. Easy. Now, this makes more sense. And let's get on with the rest of our diagram. This is the diagram we needed. And see how they've given all this information? Let's just, give this side to writing the basics. Okay, so what they want us to figure out is that vector A is this. So what's the vector OA? So from the origin, assuming this is the origin, I need to clean my iPad. Okay, so OA will then become -3, 1. Okay, this is setting out the basics, right? Then OB is equal to 3, 4, and OC is equal to -4, 8. Nice. Now we also get that okay, we want to find these lengths. Okay, so then AC is equal to OC minus OA, and AB is equal to OB minus OE. So now to OC, well, yeah, we can just perform the calculation straight away. OC is here, OC is here, and OA is here. So it's just a matter of subtracting the vectors. What is this? 4 minus -3. Wait, it's -4. Yeah, -4 minus -3 is -1. And 8 minus 1 is 7. Okay. And similarly in the bottom it's 6, 3. Easy. These are our basics. This will help us guide through the rest of the solving the sums. Okay. Now, triangle ABC has these vertices. Yes. Let's actually focus on the question now, guys. We want to find, okay, finding one of its angles. We can find any angle, but let's choose to find this angle. Okay, easy. So now that we set a base angle, let's go ahead and solve the question. They want us to find the area of the triangle. So first we can go on by finding this angle. How can we find this angle? By using our usual vector methods, which is cos theta is equal to AC and AB vectors. Okay, they're just going to treat these as two vectors, and this is the angle between them. Okay, cos theta is equal to, before we write the cos theta, let's go on and do our basic analysis in our, what is it again, guys? Star. Exactly. Let's do our basic analysis here. So what is vector AB? Remember our vector AB. Okay, let's go write the magnitudes of vector AB and AC. Okay, what are the magnitudes? Well, AB's magnitude is just 6 squared plus 3 squared, whole thing under a square root, which is 3 root 5. And AC's magnitude, remember, is again square root minus 1 plus 7 squared, which is just 1 squared plus 7 squared, which is 5 root 2. And if we dot product both of them, so AC into AB, we will result in a scalar. What is that scalar? Well, minus 6 plus 21. So 21 minus 6, which is 15. And well, we can just nice. So that is a star 1. Okay, that has all the basic information. Now we can actually go on and solve the question, which is saying cos theta is equal to, remember, the top is our vector product, so AB into AC, and the bottom is just 5 root 2 into 3 root 5. Okay, and the one, what is this? Because don't we need to find the cosine of theta? Let's see, 15 over 5 root 2 times 3 root 5. Okay, so I'm getting root 10 on 10. Okay, fully rationalized form. Now, what can we do with this? Well, see how this is the cosine of theta? There are two ways you can convert this. You can one go and be like, oh yeah, take a right angle, take theta. What's theta? Well, theta, cos theta is equal to root 10 on 10, which is, this is the adjacent side, this is the hypotenuse. Then what's this side going to be? Because that's our sine theta, right? We're just going to do 10 squared minus 10, and we're going to square root this answer, which is 3 root 10. But there's another way you can do this, and probably a much smarter way, which is, realize that sine theta is equal to sine theta. That makes sense, right? Sine theta is sine theta. So then sine squared theta is equal to sine squared theta. Okay, makes sense. We're just squaring both sides. But remember how sine squared theta can be written as 1 minus cosine squared theta. Sine squared theta is equal to 1 minus cosine squared theta. And then you know you can take just sine theta is equal to square root of 1 minus cos squared theta. Yeah, we can do this. And see how this is in cos theta. So what we can do quite simply is, using this identity, sine theta is equal to 1 minus cosine squared theta, we can do 1 minus root 10 on 10. Okay, so let's do the square root of 1 minus root 10 on 10. Which is equal to... Oh, hey, sorry. You can't just put root 10 on 10. This is because this is cos theta. If you square this root 10 on 10, root 10 on 10, answer, square the answer, it's 1 on 10. So 1 minus 1 on 10. Okay, and what's square root of 1 minus 1 on 10? Well, it's equal to 3 root 10 on 10. Okay, so this is a sine of theta, and you can put this into another box. Okay, but this box, of course, it can go in a much smaller video. All right, nice. So now we know that sine theta is equal to 3 root 10 on 10. Nice. Now, what do you want to do? Remember our area of the triangle ABC is equal to half AB sine C. What's your A? AB, 3 root 10 into 5 root 2 into sine of 3 root 10 on 10. Easy peasy. But we don't need to put this because this is sine theta, so we can just put this as this. Okay, punch all this into your calculator. 1/2 into 3 root 5. Ensure you're typing it in correctly, because I made a mistake right there. And that's just equal to 45 on 2. Because it's area, you got to include that unit square. Easy. So see, not a particularly hard problem, but it really did depend on knowing your fundamentals, right? Really? Not a bad problem, but yeah, that's all that I have to say here. Let's look at the next question. So the angle between vectors u and vector b is 60 degrees. If alpha is equal to 10 and beta is equal to 6, evaluate a minus 2b. And we have to think a little bit smartly here, because what we got to think is that, alrighty, sure, a minus 2b, you're given it. So then how can I make, because you only given me a and b, I need it individually. Anytime these kinds of scenarios come up, just square both sides. Square both sides, and then you can take it as a dot product. Simple. So see here, vector a minus vector b is equal to, if we square this, see that? Exactly. Now, what you can do is that you can expand. So this is just magnitude of vector A squared plus 4 magnitude of vector B squared plus, I don't really know if it's a plus, but it's just going to be minus 2ab minus 4. Easy peasy. Yeah, this is what we want. We know a, so this is just a matter of subbing in. 10 squared plus 4 into, what's vector b, magnitude of b, 6 squared minus 4, what's a, 10, into b, 6. So 10 squared plus 6 squared times 4, and then there's the minus 4 times 10 times 6. And because they've given us this fact that the angle between the vectors a and b is cosine of theta, they didn't give that for fun. And when you're doing dot products of two vectors, it's always important to keep that into consideration. So cosine of 60, but you don't really need to write that because you can evaluate cos 60 to be half, so you can just times the entire thing by half. Simple. Gotcha. Easy. When you go ahead and punch this into your calculator, you're going to get a result of 124. But remember how they only asked you vector a minus 2b magnitude squared? Magnitude, they didn't ask you the squared, so you're just gonna square root it to get a minus 2b. Okay, and what's square root of 124? Well, that's just equal to 2 root 31. And that's your answer. Well done. So similarly, I will let you guys do question B on your own as homework for this exercise. Hopefully you had enjoyed it. Bye.